everyone. For the given sequence, we're going to find the positive integer, the value of the positive integer n, such that the sum of the 1 divided by a sub 1 all the way to 1 divided by a sub n equals 10. So this one, what we're first going to do is rewrite these first three terms here so we can see the pattern better. So basically, if we have square root of 3 plus 2 square root of 2. Now I can rewrite this as square root of 2 plus 1 plus 2 square root of 2 times 1. Now what I'm doing is I'm using the fact that a squared plus 2ab plus b squared equals a plus b squared. So for this one, I'm going to rearrange everything and get 2 plus 2 square root of 2 times, I can go ahead and write this as square root of 1 plus 1. That means this part right here is your 2ab. So in this case, we have 2 square root of 2 times square root of 1. My a equals square root of 2, and my b equals square root of 1. Therefore, I can rewrite this as the square root of 2 squared plus 2 square root of 2 times square root of 1 plus square root of 1 squared. All right. And then this equals a plus b squared. So this is going to be square root of 2 plus square root of 1 squared. And this goes away here, and you're left with this equals square root of 2 plus square root of 1 is just 1. So there's that. All right. The next one, we do the same thing. We have 5 square root of 5 plus 2 square root of 6. So what I'm going to do is write this as square root of, since I have a 6 here, I'm going to use 3 times 2 is 6. So 3 plus 2 is going to be my 5. And then we write this as 2 square root of 3 times square root of 2. Then I'm going to rearrange it and get square root of 3 plus 2 square root of 3 times square root of 2 plus 2. Now, looking at that, that means my a is square root of 3. My b is going to be square root of 2. So now I can write this as square root of 3 squared plus 2 square root of 3 times square root of 2 plus square root of 2 squared. And this is going to equal square root of 3 plus square root of 2, using the same properties of this. And the square root goes away. So now we have this one. So we're going to be comparing these two here. All right. And then the next one is square root of 7. Now we have this square root of 10. So what I'm going to do is let me write it out so you can see it's kind of small. Plus 2 square root of 10. So what I'm going to do is write it out as 5 plus 2. So that means I can write this term as 2 square root of 5 times square root of 2. And then rearrange it. So we're going to have square root of 5 plus 2 square root of 5 times square root of 2 plus 2. Now this can be written as the square root of 5 squared, because your a is going to be square root of 5. Your b is square root of 2. Then you're going to have plus 2 square root of 5 times square root of 2 plus square root of 2 squared. So everything's all matching up and equaling, and then all you have to do is we want a plus b squared. So this is going to equal square root of 5 plus square root of 2. once we condense it like that, because the square and the square root sign will go away. So now we have a different sequence, and we can write this as the terms we got were, instead of using these, we want to use square root of 2 plus 1, square root of 3 plus square root of 2, and then we have this last one with square root of 5 plus square root of 2. All right, now that means we're going to look for a sub n, and that's going to be square root of n plus 1. If this is a sub 1, a sub 2, a sub 3, and then we're going to have plus square root of n. All right, and if you substitute in these index numbers here, this formula works. All right, and this is for n is greater than or equal to 1. All right, now we have this formula. All right, so basically I can rewrite this formula as the sum from k equals 1 to n of 1 divided by a sub k. And that's going to equal the sum of k equals 1 to n, and a sub k, we're going to let it be this. So that's going to be 1 divided by, instead of n, substitute in k. So you're going to get square root of k plus 1 plus square root of k. Okay, I'm going to rewrite this again. We're going to have to simplify this. So we have the sum of k equals 1 to n, and then in the denominator we have square root of k plus 1 plus square root of k. In the numerator we have 1. And I'm going to multiply this by the conjugate. So the conjugate is square root of k plus 1 minus square root of k. So I have to also multiply the numerator by this. So we're going to have a square root of k plus 1 minus square root of k. Now the denominator is what we have to work on. So this is going to be a plus b times a minus b. This equals a squared minus b squared. So basically what we're going to get is the sum k equals 1 to n. The numerator is just going to be square root of, let's make this a little bigger, k plus 1 minus square root of k. And this is going to be equal to, and I'm just going to do it over here. You square this square, k plus square root of k plus 1 squared is just k plus 1 minus k. So basically we just have a 1 because the k's cancel. So our denominator is just 1. All right, and we don't really need to put that, so let's erase that. So this is what we have now. Now let's write out some terms. We're starting with k equals 1, and that's going to give you square root of 2 minus square root of 1. And then when k is 2, you're going to get square root of 3 minus square root of 2. When k is 3, you're going to get square root of 4 minus square root of 3 plus dot 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 plus, we go to n. Your last term is n. So that's going to be square root of n plus 1 minus square root of n. This is a telescope series, so we're going to see the pattern of what we can cross out. And what we're crossing out is this first term with this last term. So it's this first term with this last term. This first term with this last term, and this first term with this last term. And it's always good to see the pattern so you keep, especially for this middle part, because we got to be careful what we cross out here at the end. So basically what we have is this square root of n plus 1 minus 1. All right, now this all equals 10. So set it equal to 10, and then add the 1, so you're going to get square root of n plus 1 equals 11. And then let's square both sides. So you're going to get n plus 1 equals 121, and then subtract the 1. So our positive integer n is going to equal 120. And that is your final answer. Thank you. Have a nice day. Bye-bye.